Question says state Ohm's law. So Ohm's law says the current through a conductor. Remember, current goes through. Goes through. The current through a conductor is directly proportional to the potential difference across. So the potential difference is across the conductor, whereas the current is through a conductor. So the current through a conductor is directly proportional to the potential difference across the conductor, but there is a catch, provided the temperature of the conductor is remaining constant. So that's Ohm's law. So this is where we derive from here V is proportional to I. Then ultimately, when you move with it, after saying V is proportional to I, that's when we then say introduce the constant, but the constant is the resistance, like that. So this comes about from Ohm's law. Okay, so the next question. The variation of current I with the potential difference V for a filament lamp is shown in Fig 5.1. So this graph is the graph of current against the potential difference for a filament lamp. It is obvious that it doesn't follow Ohm's law because current here is not directly proportional to the potential difference. If it was directly proportional, it would be a straight line passing through the origin. Here the graph is passing through the origin, but it is not a straight line. So the graph of current against voltage for a filament lamp shows that the filament lamp is not an ohmic conductor, as it does not obey Ohm's law. The resistance of the filament lamp increases with potential difference. State how Fig 5.1 shows this. We want to state how Fig 5.1 shows that the resistance of the filament lamp increases with the potential difference. Now, if you check out the graph here, you can see that at all points, the ratio of voltage over current increases as potential difference increases. So potential difference is increasing in this direction. So the ratio of potential difference divided by current. Let's take, for example, this instance. Potential difference is 2 divided by the current here, which is approximately 0.75. So if you come here, potential difference is 4 divided by current, which is, let's say, 1.25. So as you can see here, we are dividing current to voltage 2 by current 0.75, sorry. But here we are dividing, even though the voltage has been doubled. Doubling the voltage, the current has not been doubled. Current has changed from 0.75 to 1.25. If it had been doubled, it would have gone to 1.5. But it has gone to 1.25, meaning that the current is not increasing at the same rate as the increase in voltage. So voltage is increasing more than the current, meaning that if voltage is increasing more than the increase in current, which means that the overall ratio of voltage over current is increasing, because they are not if voltage is doubled, current is not doubled. Current is multiplied by a factor less than the double, meaning that the current is increasing at a lesser rate, the denominator is increasing at a lesser rate. So the ratio overall increases as the potential difference is increasing. Now this ratio, remember, the question was saying state how Fig 5.1 shows this. Show what? Show that the resistance of the filament lamp increases with potential difference. Remember, resistance is equal to voltage over current. So as we have shown that V over I is increasing as voltage is increasing. So in other words, the resistance is increasing as voltage is increasing, as shown by the graph. Explain why the resistance varies in this way. So the question becomes, why is it that the resistance is increasing as voltage is increasing? What is the explanation which can explain why the resistance is increasing as voltage is increasing in the filament lamp? The reason is this: as the PD increases, as potential difference increases across the lamp, for example, current also increases. It's only natural. potential difference increases, then the current flowing in the filament lamp has to increase. There therefore are more collisions between charge carriers and ions. So the point is this one: if there's more current, there's more charges flowing. There's more charges flowing, more current, because there's now more potential difference. So more charges flowing means that these charge carriers, these charges that are flowing, are going to collide among themselves. They are going to collide also with positive ions that are left in the metal. So the more collisions there are with the positive ions, because there are more charged, the more charges, meaning that the positive ions will gain more energy. So when the positive ions are gaining more energy because they are colliding with the charge carriers, the positive ions are getting more energy, they vibrate more. So when the positive ions vibrate more, it means that they are going to be blocking the movement of they are vibrating more because they've got a higher temperature, they've got higher energy, meaning that they are going to block the movement of charge carriers. And when they block the movement of charge carriers, because they are now vibrating more, because they now have more energy, more temperature, it means that there is now more resistance.